All right, so what we have here, guys, is 2003 question 1. It's a calculator problem. It says, let R be the shaded region of the square root of x, which has to be the top curve, and e to the negative 3x, which is an exponential curve, right? Decreasing exponential curve is the bottom curve. All right. All right. Now, it says with a vertical line 1, and it draws everything for you in this pretty picture, but it doesn't give you the intersection point of A. Do you guys agree? But it does show you 1. So here's what I would do initially if I was doing this problem. I wouldn't get A right away. I'd say, okay, region R. R is equal to the integral from A to 1 of square root of x minus e to the negative 3x dx. But I can't get the answer without finding letter A. All right? Guys, to get letter A, we're just going to have to use our calculator.
Yeah, Morgan.
Mr. Anderson, are you?
So I have to find A at this point. Guys, to find A, I'm going to use my TI-84, because that's what I have. And in the solver, guys, I'm going to type square root of x minus e to the negative 3x equals 0 and say, oh, calculator of mine, what is that point? All right? And when I do that, I get x equals, and I only go 4 decimal points, 2387. All right. Awesome. We reset it. So now we go from 0.2387 to 1.
I thought it was really easy.
All right. And if I do this, did you guys get 442?
4.4426. Yeah.
Now, everybody, let's score this. This is all I'd write for letter A. Let's score this.
Do we have to write this?
No, you don't.
Question. On the AP, do you get more room to write?
Basically, you get a blank page.
Oh, yeah.
One blank page for every problem. We'll talk about spacing.
I was gonna say, because I like to do my work on top, like next to
You're going to want to copy that down later then. Okay, we'll talk about more about that when we get through some more problems, okay?
Okay.
All right. Everybody, now listen. I'll have to come back. The first point is correct limits in integral A, B, and C. So you need to get the limits of integration, A to 1, right, in all 3 sections to get a point. We'll come back to that one. But for letter A, there are 2 points. The integrant and the answer. All right? The integrant and the answer, 2 points. And you got to have, we're going to have to remember these integrants and see at the end if you got them all for all 3 problems. So that's letter A. So I group it, I minimize it, I stick it up here, boom. Letter B, find the volume of the solid generated when R is revolved about the horizontal line, y equals 1. So everybody, I'm going to revolve R about this line. Oh wait, y equals 1. Not negative 1. Y equals 1. I'm going to revolve it around here. Now, this might not have a hole at the end, John, but this is still a disk, buddy. Right? This will be a disk. So volume equals, huh? A washer. I'm sorry, I said disk, didn't I? No, it's a washer.
Yeah.
God, I can't even joke with John right. I made the wrong joke. It's a washer. Now, everybody, the reason I like defining A in the first problem, or I might just write A equals 0.2387, is that once I write that, I can keep using A in my limits instead of writing out the digits. Okay, and this is going to be AX dx. You guys agree? I'm going to do this. I'm not going to use cylindrical shells. No way, no how. Because that would have to be with respect to the y-axis. I don't want to try to solve this for y. We're going to go back to our old faithful. Again, I see a washer. I see A to 1 pi RO minus pi RI dx, right? Where I have to figure out my RO and my RI. What I see here is that my RI is to the top curve, right? And my RO is to the bottom curve. So I'll start with my RI. I see that it's y high to that plus ri equals 1. So ri plus y equals 1, right? But so if I solve it, I get ri equals 1 minus, top curve is square root of x. Once I've set this for ri, I can write ro. If you're getting this without this amount of work, fine. But this is just, again, what I've learned with time with students is a lot of times we don't see the right ro and ri's. All right, the next thing I would write here then, after I had that circle, is just plug it in. Put the pi on the outside. I would do that. And I'd go, this is the last line I expect to write, so I'd probably go 0.2387 to make sure I enter my calculator correctly. 1 minus e to the negative 3x quantity squared minus 1 minus square root of x quantity squared dx. All right, if I enter this in my calculator, I get 0.543 pi, but that's not what I would write. I would write 1.423. It's something like 6. Now, everybody, I want to be clear about this. The reason I make you go 4 decimals, when we score this, they scored a point for 1.23 or 1.24. They went 3 decimal places. By going to the 4th decimal place, we remove the chance that you screw up a 6th grade algebra math skill. You see what I mean? That's why we go 4 decimal places. All right, so let's score it. That's the answer. It is worth 3 points total. 2 points for the integrand. 2 points for this. If you did not get this, if you made this reverse, if you reversed these 2 parts, okay, you still got a point. It's -1 for reversal. It's -1 if you screw up the pi. If you forgot pi, it's -1. If you omit 1 radius, if somehow you just did half of this, they took away only 1 point, which surprises me. I usually would have thought if I would have figured if it was a disk, you would get it all wrong. But that's 2 points, all right? And then you get 1 point for the answer. Okay, so 3 points. And again, if you got the limits right so far, you're on your way to earning 1 point, right? If you have the right limits here for A, B, and C. All right, so let's group this and go on to the last part, letter C. And letter C is not, I bet you it's not perpendicular. Haven't done it for a year. I'm going to guess it's the same type of problem, but different shape. Is that what it was? R is the base of a solid. For each solid, the cross-sectional perpendicular to the x-axis is a rectangle. Woo! Not a circle. Whose height is 5 times the length of its base in region R. All right. So now, region R is a bunch of rectangles, guys, where this base is the width, and the height going away from it is 5 times that length in the blue. All right. So listen, our integral doesn't change. We know A is equal to 0.2387, right? I know the volume equals, in this case, A to 1, AX dx. But guys, when I draw the rectangle, AX is not a disk or a washer. It's a rectangle. And when I draw that picture, everybody, do we agree this is the top curve minus the bottom curve for a length? That is this. And it says what? The length of this rectangle, or the height of it, is 5 times. So this is 5 times this. Does everybody see how I got this? I'm going awfully fast. All right. So now it's easy. What's the area of a rectangle? Length times width, right? So I'm only going to write one more integrand here. I'm going to write equals 0.2387 to 1. 5 times square root of x minus e to the negative 3x quantity squared, because it's this times that, dx. And I type it in my handy dandy TI, and I get 1.554. And everybody, here we go. Now listen, at this point, if you've had 0.2387 to 1 for all three problems, give yourself a point. Then there are three more points in this one. This integrant is worth 2 again. This answer is worth 1 again. Now, eventually, everybody, we should easily get all 9. Right now, I would hope you got at least 6. Maybe C through you, but for sure, A and B should have been gimmes with a calculator, all right? This is a 6-pointer, okay? Sam, John up there, this has to be 6 points in May. We can't let an easy one like this go by because you will screw up a different one somehow, some way. This is a low-hanging fruit.
All right, Mr. Anderson, I got a composition for you.